Hello everyone, welcome to my YouTube channel. My name is Benny Hen and I am doing my first year of engineering in CSE Cybersecurity in Sri Venkateswara College of Engineering, Bengaluru. So today I would like to explain about the topic called corrosion. We shall know about its definition and its types, and also we shall know how to prevent corrosion. So, coming to the introduction part, corrosion is a natural process that involves gradual deterioration or destruction of materials due to chemical reactions with their surrounding environment. This process often results in the loss of materials and also can weaken the integrity and functionality of an object. Corrosion is a common problem in various industries and can be caused by the factors such as moisture, oxygen, chemicals, and temperature. And we know the basic example is rusting of iron. So, under this example, we can see two reactions, that is, oxidation reaction and reduction reaction. When we look into oxidation reaction, it is known as loss of electron, where Fe iron undergoes oxidation and liberates electrons, and whereas in reduction reaction it is known as gain of electron, and we can see that electron which was liberated by the iron is gained by this so-called oxygen and water and forms hydroxide. The overall reaction is known as redox reaction, where we can see ferrous hydroxide is the main part which we called as rust. Under corrosion, if we look into the types, we see two types of corrosion, that is differential metal corrosion and differential aeration corrosion. Differential metal corrosion. Differential metal corrosion is a type of corrosion that occurs when two different metals are in contact with each other in the presence of an electrolyte, such as moisture or an aqueous solution. In this electrochemical process, one of the metal acts as an anode and gets corroded rapidly, while the other metal acts as a cathode and remains relatively unaffected. The rate of corrosion depends mainly on the difference in potential. Between two metals, higher the difference, faster is the rate of corrosion. When we look into the example, when iron is in contact with copper of 0.34 volts, iron, where minus 0.44 is the volt, becomes anodic and undergoes corrosion, whereas copper cathodic remains unaffected. So, coming to the second type of corrosion, differential aeration corrosion. It is a type of corrosion that occurs when different areas of metal surfaces are, are exposed to varying levels of oxygen or other oxidizing agent. This non-uniform exposure to oxygen creates an electrochemical potential difference between different regions of metal surfaces, leading to accelerated pollution in some areas while other areas remain relatively unaffected. Totally, this explains that wherever the oxygen level is less, there corrosion takes place, and wherever the oxygen level is high, there corrosion does not affect. Such examples are part of a nail inside wall undergoes corrosion, and also partially filled iron tank undergoes corrosion inside water. Some other typical examples of corrosion are waterline corrosion and pitting corrosion. And coming to the corrosion controlling method. Corrosion can be controlled preventing the formation of galvanic cells on the surface of metal. There are many methods of controlling corrosion, but for now we shall look into the protecting coatings. A protecting coating method is also called as giving a protecting layer or to the surface of an object to prevent it from deteriorating or being damaged due to various factors such as corrosion. The primary purpose of protective coatings is to extend lifespan of an object or a material, improve its appearance and maintain its functionality. Under this, again, it's classified into two types, that is, inorganic coatings and metal coatings. Coming to the first one, metal coating. Metal coating is a process of applying a layer of metal onto the surface of another material, typically a substrate made up of different material. The primary purpose of a metal coating is to provide a range of desirable properties to the substrate, such as enhanced corrosion resistance, improved aesthetics, increased durability, electrical conductivity, and under this there is anodic coating, which is coating metal is anodic to the base metal. Such the example of this coating is galvanization. Galvanization is a process used to protect or steel from iron or steel from rust and corrosion by applying a layer of zinc to the surface. It's commonly used for making things like galvanized pipes, fences, and car parts. Here's a simple explanation of galvanization process. Cleaning. The iron or steel surface is thoroughly cleaned to remove any dirt, rust, or impurities. This is essential to ensure good addition of zinc coating. Second is pickling. The cleaned metal is soaked in an acid solution, usually hydrochloric acid or sulfuric acid, to remove any remaining oxides and create a clean, smooth surface. And the third is fluxing. The metal is dipped in a flux solution, which helps the zinc adhere better to the surface and promotes even coating. So, coming to the fourth one, galvanizing. The cleaned and fluxed metal is immersed in a bath of molten zinc, typically at a temperature around 450 degrees Celsius. This hot dip process allows the zinc to bond with the metal. The fifth one is coating. As the metal is removed from the zinc bath, it forms a protective layer of zinc on its surface. This layer acts as a barrier preventing the moisture and oxygen from coming into contact with the underlying iron or steel. The sixth is cooling. After galvanizing, the metal is allowed to cool. This solidifies the zinc coating and makes it more durable. Inspection. The galvanized product is inspected to ensure that the zinc coating is even free from defects and meets quality standards. Finished product. The galvanized metal is now ready to be used in various applications where corrosion resistance is important. As you can see, the process of galvanization goes like this. And coming to the second one, inorganic coating. An inorganic coating is a protective layer or surface treatment applied to the materials, typically using non-carbon based compounds to enhance their durability, corrosion resistance, or other properties. Example is anodizing. Anodizing coatings are generally produced on non-ferrous metals like aluminum, zinc, magnesium, and their alloys by anodic oxidation process in which the base metal is made as anode. As we can see, anodizing of aluminium preparation. Clean the aluminium surface to remove any contaminants and ensure a smooth finish. Second is anodizing bath. Immerse the aluminium in an electrolyte solution, typically sulfuric acid. The third step is electrolysis. Apply an electric current to this aluminium, which forms an oxide layer on the surface. Fourth is oxide formation. The aluminium reacts with oxygen, creating a durable and protective oxide layer. Thickness control is the fifth step. The anodizing process can be controlled to create a desired oxide layer thickness, typically measured in microns. Dye is the sixth step. If desired, a dye can be added to the process to color the anodized layer. Sealing. Submerge the anodized aluminum in a hot water or nickel acetate solution to seal the pores in the oxide layer. And the final finish thing is rinse and dry the aluminium, resulting in a durable, corrosion resistant, and often colorful surface. Anodized aluminum is widely used in various industries for its improved durability. As you can see in this picture, the anodizing of aluminum, the process goes on like this as shown in the diagram. So coming to the last part of this topic, corrosion penetration rate. The corrosion penetration rate, or CPR in short, is the speed at which any metal or alloy loses in a specific corrosive environment through chemical or electrochemical reactions. It's defined as the amount of weight loss per year in the thickness of metal or alloy due to corrosion. It depends on the factors like nature of metal, nature of corrosive environment, nature of corrosion product, also speed at which corrosion spreads in the inner portion of a metal. It is calculated using this formula as you can see, and the units of CPR is MPY or MMPY. So the formula is this, and whereas in the formula W denotes weight loss of the metal and T denotes time taken for the loss of metal, rho denotes density of the metal, and A denotes the surface area of the metal, and K denotes a constant. So with this, we come to the end of this topic. Thank you everyone for watching this video. If you really like the video, please like, share and subscribe. And see you guys in my next video. Bye bye.